Good morning, students. Our today's topic is sequence of real number. Okay. Now, before going into the topic, just we revise the term mapping. Now we know that for every mapping there are two sets, namely A and B. The set A is called the domain of the mapping and the set B is called the codomain of the mapping, and the mapping is denoted by F from A to B. Clear? Now what is mapping? We all know that mapping means for every elements of domain we have unique image in codomain. So if X is in A and if Y is the image of X under the mapping, then the symbol is Y equals to F of X. Clear? Now come to our main topic, sequence. Now in case of sequence, what is sequence? In a simple word, sequence means it is a mapping whose domain is natural number. That is, in case of sequence, domain is always fixed to n. But what about codomain? Codomain is not fixed. It depends on the nature of the sequence. If we are considering sequence of real number, then codomain will be R, set of real number. If we are considering sequence of complex number, then codomain will be C, set of complex number, like that. Clear? Now next, what is sequence of real number? Sequence of real number means it is a mapping. We define it as X from n to R. N is the set of natural number and R is the set of real number, and we know that mapping means for every elements of domain that start from 1. So for 1, 2, 3, 4 like that, we have unique images in codomain. So for 1 the image is like x1, for 2 it is x2, for 3 it is x3, like that, and they are all real numbers. So we collect all those real numbers and represent it in the form within second bracket x1, x2, x3, x4, like that. That collection is called the sequence of real number. In a compact form we can represent it in the form within second bracket xn, and only xn, that is without any bracket, that is termed as the nth term of that sequence. Clear? Okay. Next, trace. What is trace? Trace means it is a set of distinct elements of a sequence. That means in case of sequence, the images may be equal, may not be equal. So if the images are equal, then trace means from that collection of images we just identify the distinct elements and construct a set with the help of those elements. That is a trace. Okay. Okay. Now for examples, first, if xn is n square, if xn is n square, then what will be our sequence? The first term is 1, then second term is 4, third term is 9, and like that. So the sequence will be within second bracket 1, 4, 9, 16, and so on. If next example, if the nth term is 2n minus 1, then what is xn? Xn is 1, 3, 5, 7, like that. If xn is minus n, then the term will be minus 1, minus 2, minus 3, minus 4, and so on. Similarly, if xn is 1 by n, the elements of the sequence are 1, then half, then 1/3, 1 by 4, and so on. Okay. But in example 5, look at that. If xn is minus 1 to the power n, then the first term is minus 1, then next term is 1, then again repeat, it's minus 1 again, then 1. So the members are repeated, minus 1, 1, minus 1, 1, like that. Similarly, if xn is 1 plus minus n, minus 1 to the power n by 2, then the elements will be 0, 1, 0, 1, like that. And in the last example, if xn is 5, then all the elements of the sequence are 5. Okay. So look at the difference. In the first 4 examples, all the elements of the sequences are distinct. That's why in the 4 examples, trace of the sequence and the sequence itself are identical. But consider the last 3 examples, 5, 6, and 7. In example 5, the elements of the sequences are repeated and the distinct elements is minus 1 and 1. So what is trace? Trace is a set containing minus 1 and 1 for example 5. Similarly, for example 6, what is a trace? It is a set considering the elements 0 and 1. Similarly, for the last example, trace means it is a singleton set just containing the element 5. Clear? Next topic is bounded sequence. Now in this context of bounded sequence, first we need what is bounded above sequence. Bounded above sequence means Just look at the definition. A sequence xn is called bounded above if there exists a real number, we call it u, such that xn less than equal u for all n. That is, every elements of the sequence is less than or equals to u, that is no one cross u. Okay, then the sequence is called bounded above and the number u is called the upper bound. Just look at the diagram. Here the red horizontal line that represent the x-axis, and we know that elements of the sequences are real number, and real number means they are the points on x-axis. So all the blue dots, they are representing the elements of the sequence. Now for that example, if we can construct a wall, just like a wall u, such that no elements of the sequence cross that wall, clear, then that wall, that is u, the real number, that is called the upper bound and the sequence will be bounded above. Clear? If we consider our example again, look at the first example, xn is n square. So the terms of the sequences are 1, 4, 9, 16. That means the elements are gradually increases. That means it has no upper bound, so the sequence is not bounded above. Clear? But if we are considering example 3, xn is minus n, then the elements are minus 1, minus 2, minus 3, minus 4 and so on. That means all the elements are gradually decreases. So the maximum member is minus 1, that means it is bounded above. And as minus 1 is the upper bound, then 0, 1, 1.5 all are upper bounds. Okay, so from these two examples we can conclude that either a sequence is not bounded above, that means either a sequence has no upper bound, but if it has upper bound, then that number of upper bound becomes infinite. Clear? So we have, for a bounded above sequence, we have infinite number of upper bounds. Now from that set of upper bounds we identify the least one, then that list of those upper bounds, that is called the least upper bound or supremum. Okay, next, bounded below sequence. What is bounded below sequence? Bounded below sequence means there exists a whole number L such that xn is greater than equal L for all n. That number is called the lower bound and the sequence is bounded below. Just look at the diagram again. If we construct a wall from left, that is, if we can find a real number L such that no elements cross that wall from on the left, then the sequence is called bounded below. Clear? And same thing is here, either a sequence has no lower bound, and if it has lower bound, then that number of lower bound becomes infinite. So from those infinite number of lower bounds, if we consider the greatest of that set of lower bounds, then that is called the greatest lower bound or infimum. Okay, now come to bounded sequence. What is a bounded sequence? Bounded sequence means it is bounded from either side, that is, it is both bounded above as well as bounded below. So in case of bounded sequence, we must have two real numbers L and U, such that L less than equal xn less than equal U for all n. Clear? That means we have wall from either side. Okay, alternatively we can define a bounded sequence in another way. A sequence xn is bounded if there exists a positive real number. Look at that term, positive real number k, such that mod of xn less than equal k for all n. So if we remove the mod sign, then we have minus k less than equal xn less than equal k. So it has again upper and lower bound. That's why it is bounded. Clear? So if we consider our examples, look at that. The first example, it is clearly bounded below because 1 is the lower bound, but it is not bounded above. But example 2, again it is bounded below but not bounded above. In example 3, it is bounded above because minus 1 is the upper bound, but it is not bounded below. But example 4, it is bounded because it has lower and upper bound both. 0 is the lower bound, 1 is the upper bound. Clear? Now example 5, again it is bounded because 1 is the upper bound, minus 1 is the lower bound. In example 6, 0 is the lower bound, 1 is the upper bound. And in example 7, 5 is always an upper bound as well as 5 is the lower bound. Clear? Now next topic is monotone sequence. Now in that context, first we need monotone increasing sequence. So a sequence xn is monotone increasing if it satisfies this condition xn plus 1 greater than equal xn for all n. That means when n is 1, then x2 greater than equal x1, x3 greater than equal x2, like that. That means the elements are gradually increases one by one, then we call it monotone increasing. And if it is happen that xn plus 1 greater than xn only, there is no equal sign, then we call it strictly increasing sequence. Clear? Similarly, what is monotone decreasing sequence? Monotone decreasing sequence means a sequence xn is called monotone decreasing if xn plus 1 is less than or equals to xn for all n. Okay, that means the elements are gradually decreases one by one. And if xn plus 1 is less than xn for all n, strictly less than, then we call it strictly decreasing sequence. Okay? And finally, what is monotone sequence? Monotone sequence means it is either monotone increasing or monotone decreasing. Okay, if it is monotone increasing, still we can call it monotone. If it is monotone decreasing, again we can call it monotone. Now look at the example. If we consider a sequence xn where the nth term is 5n plus 3 by n plus 5, then first we are considering xn plus 1 minus xn. Now what is xn plus 1? Xn plus 1 is the n plus 1th term. So we are just considering the difference between the n plus 1th term and nth term. And look at the difference. It is 22 by n plus 5 into n plus 6. What is n? N is a natural number. Natural number is always positive. That means the ratio is a positive quantity. So xn plus 1 is greater than xn. That means the sequence is increasing. So whenever the question is verify whether a sequence is increasing or decreasing, then we are always doing the same thing. Clear? We are just considering the difference between the n plus 1th term and nth term. If it is positive, then it is increasing, and if it is negative, then decreasing. Okay, clear? Okay, so that's all for today. Thank you.